The question is how many electrons must be removed from a piece of metal to give it a positive charge of 1 into 10 power minus 7 coulomb. So here what they asked is we need to find out a number of electrons which have to be removed from a piece of metal so that it acquires the positive charge of 1 into 10 power minus 7 coulomb. So we know that the formula is Q is equals to Ne, where Q is equals to given charge, N is number of electrons, right, number of electrons, but in these they say to give the positive charge, so we need to take it as, in this situation we need to take it as number of protons. E is the electron charge, but in this case it is proton charge, which is equals to positive 1.6 into 10 power minus 19 coulomb. The negative charge value is minus 1.6 into 10 power minus 19 coulomb. So equating all of them in the formula, number of electrons or number of protons, we need to find out, and proton charge is 1.6 into 10 power minus 19. So N is equals to 1 into 10 power minus 7 divided by 1.6 into 10 power minus 19. So answer will be 0.625 into 10 power 12. So shifting up the decimal into the right, 6.25 into 10 power 11 is the answer. Electrons must be removed, right? So the next question is two positive charges separated by a distance of 2 meters each other with a force of 0.36 Newton. If the combined charge is 26 microcoulomb, the charges are, so the given two positive charge, let the positive charge will be Q and Q with the distance of 2 meter and at a force of 0.36 Newton. So, and also the given as the combined charges are, let us assume this as Q1 and Q2. Q1 plus Q2 will be 26 microcoulomb, or 26 into 10 power minus 6 coulomb, right? So we don't know the value of Q1 and Q2. First we need to the question is we need to find out the Q1 and Q2, right? Q1 and Q2 we need to find. So by Coulomb's law we know that F is equals to minus K Q1 Q2 divided by R square. Here R is 2 meter, right? F is given 0.36 equals to K is 9 into 10 power 9, and Q1 we don't know, and Q2 divided by R r square is 2, 2 to the 4, right? 4. And we need to simplify it. Q1 and Q2 equals to 0.36 into 4 divided by 9. This 9 into 10 power 9. So here the answer will be 9 into 10 power 9 into decimal will be 52, right? So 10 power minus 2, right? 4 is 16 into 10 power minus 2 minus 9. So answer will be 16 into 10 power minus 11. So if we evaluate these, we are going to shift the decimal to the right again. 116 to 10 power minus 12. So the product is getting as 160. The product is 160 into 10 power minus 12, and the sum is 26 into 10 power minus 6 coulomb. So the two charges must be equals to Q1 equals to either 16 or 10 microcoulomb, and Q2 must equals to 16 or 10 microcoulomb. This is all. The next question they asked is, two identical copper spheres are separated by 1 meter in vacuum. How many electrons would have to be removed from one sphere and added to the other so that they now attract each other with a force of 0.9 Newton? So they given that there are two identical two identical copper spheres which is separated by 1 meter in a vacuum. If both are identical means they both have the same charge, right? Same charge. The charge will be Q. They given as the force will be 0.9 Newton, and we need to find that how many electrons should be removed from one sphere and added to another sphere so that the force between them will be 0.9 Newton. We need to consider the force 0.9. So first we need to find the charge, right? So we need to apply the first Coulomb's law formula. F is equals to minus Q into Q, right, divided by R square. Here R is equals to 1 meter. If we know they given as 0.9 equal to minus 9 into 10 power 9 Q square divided by 1 square is 1. 0.9 divided by 9 into 10 power 9 equal to Q square, minus, then Q will become as 0.1, Q square will become as 0.1 into 10 power minus 9. Q will become as 10 power minus 5 coulomb. So they asked the number of electrons, right? So Q, we know that Q is equals to Ne formula. So Q is given, we find out right Q, minus q minus, so then minus 5 equal to n into 1.6 into 10 power minus 19. N is equals to 1 into, we can write here 1 into 10 power minus 5 divided by 1.6 into 10 power minus 19. So it will become as 0.625 into 10 power, then denominator will get it up numerator, so the answer will be, not the answer, minus 14, no, plus 14, so the answer will be 6.25 into 10 power 13. And then these are the number of electrons need to be removed from one sphere and added to another sphere to get the force as 0.9 Newton. So the number of electrons will be 6.25 into 10 power 13 electrons. So the next question is that a proton and an electron are placed 1.6 centimeter apart in a free space. Find the magnitude of electrostatic force between them and the nature of this force. So it is given that the next question will be, so they given one proton and one electron in a free space. The distance between them will be 1.6 centimeter. So they asked the force in between them and the nature of the force, whether it is attractive or it is repulsive. We know that proton will be positive and the charge will be 1.6 into 10 power minus 19 coulomb. Let us consider this as a q1 charge, and electron will be minus negative 1.6 into 10 power minus 19 coulomb. We consider this as q2. So the distance between them will be, we consider as r. So it is 1.6 centimeter, which will be 1.6 into 10 power minus 2 meter. So according to Coulomb's law, the magnitude of the force will be equals to minus k will be the proportionality constant q1 q2 divided by r squared. So if we put the values of k, q1, q2 and r, then the answer will be getting, so k here is proportionality constant, which is equals to 9 into 10 power 9, so minus 9 into 10 power 9 multiply by 1.6 into 10 power minus 19 into minus 1.6 into 10 power minus 19 divided by r square is 1.6 into 10 power minus 2 whole square. Minus we will get plus, positive answer, so 9 into 10 power 9, 1.6 will get cancelled, so remaining will be 10 power minus 19, this into 10 power minus 19 divided by 10 power minus 4 equal to 9 into 10 power 9 minus 19 plus minus 38, this will go up plus 4, so the answer will be 9 into 10 power minus 25 Newton. The magnitude will be 9 into 10 power minus 25 Newton, and the nature of the force we will find out by seeing the charges of the two metals or two spheres, right? Two spheres. One sphere of having charge positive, and another charge is having the negative, so the force will be the force between them will be of attraction. Due to opposite nature of charge,